Okay, today in section 4, we're going to talk about the graphs of quadratic relations. So any quadratic that we've seen before, remember a quadratic really is anything that has a square. So if I take any quadratic and set it equal to y, I can get a graph. So just like y equals mx plus p is always a line, any quadratic always makes what we call a parabola. And a parabola is just kind of a U shape like this. And it is symmetric about a line like this. And we'll call this line the axis of symmetry. So that's a pretty important part of a parabola. And we'll define how we find all these here in a second. Parabolas also have a bottom point here, which is a vertex. Now the parabola could be upside down, so the vertex could be at the top of the parabola. If it was one that looks something like this, then your vertex would be up here, and your axis of symmetry, you'll notice, goes right through that vertex. Okay? So very important to kind of know these two things, the vertex and the axis of symmetry, to help us kind of graph our parabolas. So we look at some definitions. Like we said, a parabola is just always going to be the graph of a quadratic. And we'll call it y equals ax squared plus bx plus c. So you pick some a, b, and c, and that graph will always be a quadratic graph, which will look like a parabola. Now the vertex of our parabola is going to be either the bottom, which would be the min, or top, which would be the max of the parabola. Okay. We say the x-coordinate of the vertex is always found with x equal negative b over 2a. So that's very important. So for finding this vertex, the x-coordinate is always negative b over 2a. The y-coordinate you can simply just plug into the equation. And then of course the axis of symmetry is the vertical line that splits the parabola in half. And we always find that, since it goes through the vertex like we showed before, the equation of the axis of symmetry is again x equal negative b over 2a. So this x equal negative b over 2a not only finds the x-coordinate of our vertex, it will find our axis of symmetry. So let's look at graphing a quadratic here, and we're going to do it a couple different ways. I'm going to first use a table, and then I'm going to kind of graph it on the graphing calculator. So the first thing says, graph the quadratic function y equals x squared plus 2x minus 1 using a table of values. So when you first started graphing things back in Algebra 1, we'd make our little table of x and y values. Now the problem with the parabola is you have to be very careful which ones you pick. So the first thing I'm going to pick is I'm going to figure out where is my vertex for this parabola. So the vertex we said is always negative b over 2a for the x-coordinate. Well, that in this case is negative 2 over 2 times 1. So that's going to be negative 2 over 2, which is negative 1. So my vertex is going to be negative 1 comma something. I don't really know what it is yet. And I know my axis of symmetry going to be x equal negative 1. So at negative 1, I'm going to put this little vertical line because this is going to cut my parabola in half. So I know that already. So when I'm making a table of values, all I'm going to simply do is I'm just going to pick some other x values. So I'm going to pick a couple that are smaller than negative 1 and a couple that are bigger than negative 1. But the vertex I always want in the middle. So then I'll simply just plug these into the equation. Remember, this is our equation. So we'll just plug those in. So y equals, so for negative 3, I'll go negative 3 squared plus 2 times negative 3 minus 1. Now if we figure out what that is, negative 3 squared is 9. 2 times negative 3 is negative 6 minus 1. So it's 9 minus 6 minus 1, which should be 2. So that is 1 point on our graph, negative 3 and up 2. Now the really neat thing about this is, since everything is symmetric here, I think I have this off by one spot, negative 3, 2. Everything is symmetric. So since this point is here, if I go 2 on the other side of this axis of symmetry, that point must be there too, because it must flip over this axis. So that's at 1, so I know 1, 2 is the same. You'll notice the symmetry in most of these things. Now, if you didn't like to do the math by hand, you can always use your calculator. If I go to my Desmos calculator, I have it typed in here, where I've got the negative 3 squared plus 2 times negative 3. Then I'll go minus 1. And you'll see it gives me the 2 again. So you can use the calculator that's on the Chromebooks to actually figure it out using parentheses, so you don't have to worry about the order of operations or anything. So I'll do the same thing with the other ones. If I do 0, if I put in 0, I'll get 0 and 0 and negative 1. So I know that one is going to be simply negative 1. And since this is symmetric, that's negative 1. And again, you certainly can just plug these in to the function like we did down here, but just for the sake of time, I won't do that. And then if I put in negative 1, I get 1 minus 2, which is negative 2. Negative 2 minus 1 is negative 3. So that's my vertex. My whole vertex is 1, negative 3. And again, I'm just finding these y values by plugging them in the equation. So I'll connect my points, and I get a kind of parabola. Okay. So just that easy. We use points here. There'll be some other ways. I'll show you actually can graph on Desmos to do this. But this is a really easy way. The key thing is making sure that this vertex is in the middle. And we found that, remember, by doing our negative b over 2a. So I asked some questions. Does this open up or down? Well, obviously, this graph opens up. What's its vertex? Well, we figured that out. It's negative 1, negative 3. And what's its axis of symmetry? Well, its axis of symmetry is x equal negative 1. And again, if you notice, these are the same value. The first point of the vertex has to be the same as the axis of symmetry. Okay, so the second one says basically I want to do the same thing. I want to graph negative 3x squared plus minus 6x plus 3. But I don't want to go through that whole process again, so what I'm going to do is I'm just going to graph this on Desmos. So I'm going to pull my Desmos calculator up here. And to graph on this, we've done some with linear functions, but it's the same with quadratics. I could simply put in there whatever function I want to graph. So in this case, it's y equals negative 3 x squared minus 6x and plus 3. So there is my parabola. Now here's the really cool thing about Desmos. Our vertex is this top point here. If I touch it, it actually will tell me what that vertex is. So it's telling me the vertex is negative 1, 6. That means we also know that our axis of symmetry should go right through here as well, because it always goes through the x part of the vertex. So if I now answer some questions about this, it says, well, does it open up or down? Well, obviously it opens down. And the real thing that makes that do that is you see this negative in front. That's going to make it go down. The vertex we'd found was negative 1, 6. That's what the calculator told us. It literally just tells us the answer. And the axis of symmetry is x equal negative 1. So those are all the things we got just from the graph. If you look here, you can see that there's other things you can get from the graph. You can get points on the graph. You can see there's intercepts on the graph you could get. There's a y-intercept. You can get all kinds of things you want. Another kind of cool thing is you can actually get the table we made earlier. You can actually make one of those on Desmos as well. All we have to do is hit the little setting button and hit table, and there's a bunch of points. So it actually can give you a little table just like we had in the earlier problem. So look, you can see the symmetry, it's all right there. Okay, another form that we'll see quadratics in is what's called vertex form. Vertex form is a little different. We had standard form, which we dealt with before, where everything was kind of in our nice form we've seen through a lot of our quadratic unit. If it's in vertex form, it is in where you have y equal to something squared plus another number. Well, the nice thing about this and why we call it vertex form, if you have it in this form, so if you have y equals x minus h squared plus k, so if it's in this form, then it has a vertex automatically of h and k. So you can find the vertex really easily if it's in this form. And if you notice, the h is always what's after the negative sign. So if it's a plus, the actual value will become minus. If it's minus, it actually will become plus. So let's look at an example how we could graph with this. So how do we graph the quadratic equation y equals x plus half squared minus 2 using a table of values? Well, the nice thing is I can find the vertex really easily. Because it's in this vertex form, the x part of the vertex is just the opposite of this number. It's plus 1, so it'll actually be minus 1. And the y value of the vertex is always this number. It's the k, so it's minus 2. So right away, minus 1, minus 2, I have on my vertex. I also have my axis of symmetry. It'll look something like that. So now I want to just find some other points, but I know the benefit to this versus the other one is I already know what my middle point is, right? It's negative 1, negative 2. So I could pick some other points, maybe 0 and 1. I could pick negative 2 and negative 3. I could plug those in. I could use the calculator as we did before. Any of those would be fine. If I plug in 1, I get y equals 1 plus 1 squared minus 2. So that's 2 squared, which is 4. 4 minus 2 is 2. And we know since it's symmetric, this will be 2 as well. If I put in 0, 0 plus 1 squared minus 2, that's going to be 1 minus 2, which is negative 1. So these will both be negative 1. So I know 1, 2. I know 0, negative 1. And then these are symmetric on the other side of the vertex. So if I look at this, this is what my parabola looks like. So the only benefit really of this is you have this vertex right away. If you had it in the other form, you just have to use your negative b over 2a. Okay, so what can we say about this graph? Does it open up or down? Well, it opens up. The vertex we know is -1, -2, and the axis of symmetry is x equal -1. Okay. Let's look at this next one, which we didn't do a lot of work on. Does this open up or down? Well, I'm going to use the calculator to kind of graph this, just so we kind of can see what we're dealing with here. So I'm going to put this in, and I'm going to put it just in the form that we see it, and see if we can't find its vertex and everything else. So if you're not comfortable doing a lot of the tables, this calculator really will do a lot of the work for you in this section, as long as you know what the parts of the graph you're looking for are. So I'm going to type it in just like I see it. And there is my graph. I can touch here, and there's my vertex, 4, 7. And we know the axis of symmetry is going to go through that, and it definitely opens down. So this will open down. Had a vertex of 4, 7, which makes sense because look, it's in vertex form. The opposite of -4 is 4. And then there's my 7, and the axis of symmetry is x equal 4. Okay, we can also go from standard form, which is our y equals ax plus b, plus or y equals ax squared plus bx plus c, and our vertex form, which we just did. And we do this by complete the square. Now this is not a necessary thing, but this is actually a really nice way to make our quadratics in both forms. So this is in standard form. So if I want to put it in vertex form, I'm going to use complete the square. So what I'm going to do is I'm just going to move the c term over. I'm just going to make some space. So what I'm going to do is I'm going to find that special term to complete the square. So I have 2 here. So when I complete the square, remember I take half of that and I square it. So half of 2 is 1. 1 squared is 1. So I will add 1 to the equation. Now I can't just add 1. To balance it out, I have to subtract 1. So these two things I added are just 0. Now if I look at these three, these factor as x plus 1, x plus 1. And then these two numbers are just -8. Well, since they're the same, I can write this as x plus 1 squared minus 8. And now this is in vertex form. So I know the vertex is -1, -8. Because remember, it's always the opposite of this. Now, could I have used the negative b over 2a formula? Sure. We just chose to convert it in this case. So it's the complete the square that allows us to convert this between forms. All right, one more. Now, if you feel more comfortable using the standard, that's fine. But it is nice to kind of have this tool in your toolkit. So same thing here. I'll move the -8 over. I'll take half of 6, which is 3. 3 squared, which is 9. So I'll add it and subtract it at the same time. So y equals x plus 3 squared minus 17. Because again, this factors as x plus 3, and this just goes together as numbers. So the vertex, now that it's in vertex form, is -3, -17. So the key things to do in this section, be able to find the vertex, find the axis of symmetry. Definitely can use your graphing calculator. That Desmos, that's going to be very helpful in these last two sections of Module 4.